Lesson 10.1 covers circles and circumference. We're first going to go through a few definitions. A chord is a segment, and I want you to remember that it's a segment. It's not a line, it's not a ray, it's a segment, and it has endpoints on the circle. So looking at the diagram we have, segment AB has its endpoints on the circle, and so that's one of our chords here. So AB. Another one would be DE because it has endpoints on the circle, so DB. One of the notations that I want to talk about is the fact that if we want to name this circle, we use this notation where this dot is the center, and we use the point that's the center. So this would be circle C. The diameter is a chord, and it's a chord that passes through the center. So in this picture, the center is C, and DE is a chord that passes through the center. The notation that we use for it is just usually the letter D. And the other thing to note is that the diameter is the longest chord. A radius, again, is a segment, not a line, not a ray. It's a segment, and the endpoints are on the circle and the center. So in this picture, we have a radius that's DC, one that's CE, and another one that's CF. The letter we usually use for it is R to stand for radius. And one thing to note is that the radius is 1/2 the diameter, and the diameter is twice the radius. So this is something we use a lot in the calculations that we're doing. Congruent circles are two circles that are congruent and they have the same radii. So two circles are congruent. If and only if the radii are congruent. So if and only if means it goes two ways. If you know that circles have two radiuses or radii that are congruent, then the circles are congruent. If you know the circles are congruent, then the radius or radii are congruent. And the other thing to note is that all circles are similar because the only thing that changes is the length of the radius. And so it's just going to dilate in and out. Concentric circles are circles that have the same center. And circumference, a lot of you have studied this before, it's the distance around the circle. So it's the length that it would take you to start at one point in the circle and walk all the way around. So it's a length. And the formula is circumference equals pi d, so the diameter times pi. Or the diameter also is 2 times the radius, so the other form is 2 pi r. So let's look at a few example problems. Looking at this first circle here, if I was going to name the circle, it would be circle F. The chords in this circle would be AC or CA, CT. Doesn't matter which order you could do it in. You could do TC, AT, and that's it in this picture. Oh, we also have NT. The diameters that are pictured in this circle is AT, and the radii that is pictured in the circle is AF, FT, and FN. Notice that they're all segments and they're marked as segments. In this picture, we're given that RT, which is the diameter because it goes through the center, and it gives us that it is 21 centimeters. So we know that RT is a diameter. And we want to find QV, which is a radius. So QV would be the diameter divided by 2, which is 10.5 centimeters. In this next problem, we're told that the diameter of circle X is 22, which it gives us that the radius is 11. We're told that the diameter of Y is 16, which gives us that the radius is 8. So if we want to look at the length of XY, it would be the diameter of X, or the radius of X, which is XZ, plus the radius of Y, which is YW, minus the overlap here, which is WZ. And we're told that WZ is 5 units. So XY would be the diameter of circle X, excuse me, not the diameter, but the radius, which is 11, plus the radius of circle Y, which is 8, minus 5, which gives us that XY is 14 units. So we're given the diameters of D, B, and A are 4 inches, 9 inches, and 18 inches. We want to find AC. So if I look at this, the diameter of circle B is 9 inches. So the length of AD is 9 inches. DC is the radius of circle D. So DC is the radius. So if the diameter of circle D is 4, it's going to be half of that, which is 2. And AC, which is this length right here, would be AD minus DC. So it would be 9 minus 2, so AC is 7. The next problem, we know that these two lengths right here are the radius, so they have to be congruent. And if we have the two sides are congruent, we know it's a 45, 45, 90. So this side would be A rad 2, and these two sides would be A. So that would make that the radius here is 3. So each of these are 3. So to do the circumference, it'd be 2 pi r. So C would be 2 pi times the radius, which is 3. So the exact answer would be 6 pi. Next we're told that we have a globe that has a diameter of 120 feet, and we want to find the circumference. So the circumference, since we have the diameter, would be pi d. So the circumference is 120 pi feet. That would be the exact answer. And the rounded answer would be approximately 376.99 feet. We want to find the diameter and radius of a circle if the circumference is 65.4 feet. So we know that the circumference is pi d. We know we have 65.4 equals pi d. So we know that if we divide both sides by pi, we have the diameter of 65.4 divided by pi, which is approximately 20.82 feet. To find the radius, we would divide that in half. So the diameter is 20.82 feet. The radius is half of that, which is 10.41 feet. And that concludes the lesson for 10.1.